Hi, welcome to this calculus lesson. We're going to take a look for my students at the chain rule homework, problem 18. So we're asked to calculate the derivative of the following function. And when they say calculate the derivative, they mean with respect to the variable. So this means calculate the derivative of y with respect to x. Unless they tell you otherwise, whatever variable is there, if there's only one variable, that's the derivative. That's the variable you're using to find the derivative. So you want to find the derivative of y with respect to x. We have a square root. So this is a chain rule problem. When we learned how to take the derivative of a square root, we just had, if you look back at those problems with square roots prior to this section, every square root we took the derivative of had the inner function, which is in this case x plus 2. The derivative of x plus 2 was a 1. So if we didn't multiply our final answer, we got y prime equals 1 over 2 square roots of x plus 2. And if I multiply that by the derivative of what's inside, well, the derivative of what's inside was just a 1. So we never told you about that. Now, I've had some people learn the chain rule, come back to me and say, I just wish you told me that. We're now multiplying by the derivative of x plus 2 with respect to x. And if I did that, that would be a 1, so it wouldn't change anything. But the first thing you do when you have a square root with some things inside is you do 1 divided by 2 times the same. Notice that function here, this and this are the same. Well, in the chain rule, we teach you some lessons like, oh, you look at, we don't just have a square root of something that's a function of, u is a function of x. So now y prime is 1 over 2 square roots of u. Notice this u and that u are the same, times the derivative of u with respect to x. So you have to figure out what's the outer function here. And it's very clear to me that the outer function is a square root, but it's probably not so clear to you. If I gave you a value for x and said find y, so I give you a number for x, and you would find the cotangent of the number, then you would square that number, then you would add it to 2, and then the last thing you would do would be take the square root. The last thing you do is your outer function. Taking a square root is the outer function. So you deal with that first in your derivative. So I'm going to find y prime by doing 1 over 2 times the square root of 2 plus cotangent squared x. I'm all done with that now. Except this only tells me how y changes with a change in 2 plus cotangent squared of x. I want to know how y changes with a change in simply x. So I have to multiply this by the derivative of what was inside, 2 plus cotangent squared x. Now, I have a new problem to do. I can forget about my original problem for a moment and just solve this problem. So let's do that step next. What I see next is I need to take the derivative of 2 plus cotangent squared x. I find it much easier with trig functions. Now, when this squared here means the whole trig function is squared, let's rewrite that. That's the cotangent of x squared. So this is a sum. I'm trying to take the derivative of a sum. The derivative of 2 is a 0. The derivative of, this is inside a squared. If I had a value for x, I would take the cotangent and then square it. This function cotangent is inside a function of squaring. So the first thing I would do is multiply. I would bring the exponent down. This is, I have basically the derivative of some function of x squared. So it's 2 times the function of x to the first power. But now I have to multiply that by the derivative of what was inside here. So this problem 18 requires you to use the chain rule twice. In the process of finding this derivative in the red box for the chain rule, I also need to use the chain rule on that. So just go through a step at a time. So I get 0, I get 2 cotangent of x. The derivative of cotangent of x is negative cotangent, cosecant. And that will give me negative 2 cotangent squared cosecant of x. Now, what was that? That was the stuff in the red box. So my final answer is y prime equals 1 over 2 square roots of 2 plus the cotangent squared of x times negative 2 cotangent squared cosecant of x. So I'm going to be able to reduce the 2's, and when I reduce the 2's, and I can't reduce anything else. You can't cross out a cotangent with square with a cotangent square, because this isn't square root. It's in a sum. It's not a factor. You can't do that. But you don't have to simplify in my math lab. You could literally write the answer as negative 2 cotangent squared. And for me, you certainly could do this. And anything you write. So that's cotangent squared of x, cosecant of x. Make sure you're understanding the separation of those over 2 square. This is y prime. And pretty clearly you could reduce the 2's if you wanted to, but you don't have to. So this is a multiple step chain rule problem, but you still do it a step at a time. The outer function is a square root. The pattern for taking the derivative of a square root is 1 over 2 times exactly the whole square root repeated. So that's why that's there. Now I have to realize the derivative that was inside is not a 1, so I do need to make sure I take care of that adjustment. So I take the derivative of what's in here. That becomes my next problem to do. Whenever I have a trig function raised to a power, when the power is on the function, it means the whole function is squared. I rewrite the problem first. That's this here. And now I take the derivative. If it's a sum, the derivative of 2 is 0. Oh, I have something squared. So this cotangent is inside of a function of squaring. So the first I take the derivative of squaring using the power rule, and I get 2 times cosine x to the 1 power less, which is a 1. And now I have to multiply that by the derivative of cotangent. And the derivative of cotangent is negative cotangent cosecant. And I just simplified this here. You didn't even have to do that for me on the test. You could have just written this whole thing here, or just even, that will go in the numerator eventually. You didn't have to make it cotangent squared. But it does look nicer when you condense things like that. You see you have a cotangent, another cotangent, so make it a cotangent squared. Okay, that's problem 18 from your homework. I hope that is helpful. I will do at least one other problem from this section and maybe more. Thank you.